трансляция тоже нужна. То есть, смотрите, это другое. Это я использую, чтобы с моим соавтором сконнектиться, чтобы его показать народу. Значит, мой поток будет такой. У меня на компьютере есть материал, я его ввожу на проектор. Иногда, может быть, чуть-чуть попишу на доске, совсем чуть-чуть. Главное...
Да, такой режим здесь есть. Вот, как бы, это как-то через вот этот компьютер делается. Здесь вот, но здесь пока ничего не включено. Надо как-то подключить.
Есть Табачникова Екатерина, видимо, да?
Ну, я не знаю, да.
Вот она должна подойти и помочь. Так мне...
Там есть кнопочка. Пауза. Вот это не пауза, вот сюда. Ну это в конце всего. Это как бы не пауза.
Что-то не работает.
Сюда нужно подключить компьютер.
Вот это
Александр, здрасте. Меня слышите? Добрый вечер. Тут такая ситуация, что, как всегда, первое занятие, нам сменили аудиторию. Аудитория большая, это хорошо, ничего не работает. Вот.
Да, но я все равно не лучше.
Мне нужно, чтобы мой сигнал выходил на проект.
Вы не знаете Черепанова?
Ой, я ему сейчас сегодня четверг. Давайте я вам позвоню, с ним мы можем это...
Ну, то есть ничего не работает, поэтому мы какое-то время предсказуемо проведем в поисках подсоединений. Вот. Но если у вас 5... Да, если у вас 5... Конечно, конечно. Если у вас 5 часов нужно будет идти, ну, значит так. Ничего страшного. Ну да. Да. Пока что народу явно меньше, чем 45 человек. Показать аудиторию. Большая...
Нужно ему трубку передам?
Ютубе транслирует. Ну,
Хорошо, можно прямо по телефону спросить?
Да, здравствуйте. Мне нужно вывести с моего компьютера видеосигнал презентации на проектор. И чтобы проектор работал на принципе. То есть мне нужно опустить. Так, как это сделать? Нет, я ничего не знаю, я впервые здесь. Екатерина тут, но она тоже не знает. Вижу, я перед ним стою. Я могу описать, что там 3 колонки: питание, запись, камера. Для начала, наверное, нужно выдвинуть эти самые экраны. Включить проектор здесь. Включить проектор 1, проектор 2. Я могу это сделать. Включить проектор 1, включить проектор 2. Буду. Давайте начнем с другого. Начнем с самого простого. Первое, что мне нужно сделать, я написал проектор. Да. Да, как подсоединить? Выбирайте стол. Да, стол. Ага, стол. Хорошо. Да. Зеленка горит, да? Кабель лежит на столе, ждем интерактива. Не вижу кабеля. Нету? Что-то валяется. Где-то там что-то рычажка панель, зеленый цвет. Вкл. Жму вкл. Да. Панель на задней стенке напротив нас. В каком смысле панель? Так, вижу, да. Так, что-то показывает. Сейчас что-то показывает. Одну секундочку, вы можете чуть подождать, потому что, видимо, у меня с мониторами там проблем. Мне нужно, чтобы у меня был правильный выбор на монитор. Сейчас, подождите. Вот, задумчиво, да. Ура, что-то выводится, но... Я знаю, потому что у меня, если я делаю фуллскрин, например, будет... Да. Хорошо, я добился того, что мои слайды будет фильтра. Ура. Так, теперь вы говорите про съемку, я правильно понимаю? Да. Да? Да. Зелененький, там нарисована камера и какая-то молния вверх. Это брезентация. Отлично. Ага. Да, именно так.
Я была там ушла и приду.
Да?
У меня просто там включены.
А что нужно? Ага. Все, я понял. Я вас понял. А еще тут валяется микрофон. Он работает? Не работает. А как его включить? Да, это да.
Я не буду пользоваться.
Могу вот эти микрофоны?
Да, это и есть микрофон петличка.
Так, микрофон петличка.
Только надо, чтобы включить, зелененький горит, значит, включен.
Так, а он работает или нет? Как понять?
Должно быть слышно.
То есть я должен себе... Через какие колонки? Ай, боже мой. Ага. Да, алло. Меня слышно? Да. Отлично, да, слышно. Кажется, слышно. Ну, достаточно одной петлички. Ага.
И не забудьте выключить трансляцию после занятия,
Угу.
потому что на YouTube
Естественно.
будет фильтр длинный.
Да.
Ну и все остальное питание там выключить.
Да, спасибо.
Угу.
До свидания.
Все?
Да? Ну что, так, только вот надо понять, как эту систему. Так что ли? Как ее? Вот так? Как ее вешать? Вот так?
Вы даже когда просто...
Вот так нормально? Окей, меня слышно? Слышно меня? Слышно, слышно, слышно. Ага, отлично. Ну все, поехали, запись. Так. Уже идет, да? Она уже идет. Ага. Мне некогда заглядывать в чат. Так, ну что же. Здравствуйте, товарищи. Значит, начнем с того, что у нас, видите, как все немножко позже началось. Из-за того, что у нас впервые такое мероприятие, и я тут впервые со всеми этими условиями. Я рад вас всех приветствовать. Кажется, вас меньше, чем записалось во всевозможные чаты и Google классы, которые мы раньше уже вывесили. Не знаю, чему это приписать. Я расскажу для тех, кто сейчас пришел. Это, пожалуйста, но как бы им предстоит узнать, что есть определенные правила, которые желательно, чтобы они приходили сюда. Итак, давайте прежде всего мы представимся. Настроя. Первый из нас это Георгий Мутафян. Нет, я вот правильный порядок, обратный порядок применяю. Значит, Георгий Мутафян. Значит, здесь написано его основные параметры творческой биографии. Закончил физтех, защищался вот здесь, на матфаке. Правда, не здесь, а еще когда матфак был на Шабловской как раз. Да. По теории представлений. Значит, роль Георгия в этом курсе огромная. Он будет вести семинары. Я тоже буду ему помогать, но он будет главный по решению текстовых задачек, которых у нас будет. Они некоторые уже появились на Google классе, о чем потом речь. Вот. Следующий снизу вверх это Александр Рубцов. Вот его фотография. Александр у нас вообще человек-оркестр. Ну, сначала его основные параметры биографии. Значит, он закончил физтех, как и Георгий. Там же защитился как раз-таки по теоретическому компьютер-сайенсу, что в некотором смысле и есть предмет этого нашего курса. Также он сейчас там, не знаю, как это переводится на русский, ассистент профессор. Александр, как переводится на русский ассистент профессор? Как правильно это перевести? Он с нами в чате.
Я вас очень плохо слышу, Дмитрий.
Ага. Ассистент профессор по-русски это как? Доцент?
А по-русски что как?
Ваша должность в физтехе.
Моя должность на физтехе — доцент.
Доцент, да, это называется доцент. Вот. Также он, значит, как это называется, принципал инженер у нас в нашей лаборатории матмоделирования. И он работает в вышке, значит, научным сотрудником в лаборатории теоретического компьютер-сайенса. То есть все очень профильно. А также, что очень важно, Александр очень опытный преподаватель алгоритмов. Вы видите, он преподает и в физтехе, и в вышке на ФКН. Раньше преподавал, сейчас не преподает. И сейчас вот в МГУ тоже появилась программа. То есть есть такая тема преподавания алгоритмов. Есть, например, школа анализа данных в Яндекс, как, скажем, одно из мест, где это происходит. Есть программы на факультетах физтеха, ФКН. И Александр очень хорошо знаком с этими программами, и он в них участвует. Ну и, наконец, я, значит, что касается меня, то я выпускник мехмата прошлого века, также защищался в прошлом веке по группам преобразования в алгебраической геометрии. Вот. Моя единственная и основная работа, я руковожу лабораторией мат-моделирования в Huawei. И вообще все мы трое, и еще 5 человек, которые будут участвовать в приеме листочков, мы все работаем в лаборатории мат-моделирования Huawei. Вот, идем дальше. Sorry, you don't speak Russian?
Oh my God. Oh my God. It's okay. We will speak English. The question is, do you understand Russian, or you don't? Not really. So you prefer that I speak English? Okay, we will. It's no problem. I can do it. Just the question is that it might be not as clear and fast as in Russian. However, yeah, our course is placed as international one, English speaking, so we can do it. Okay, we switch to English. So, what is the main target of our course? In fact, the research in the algorithms is not well known outside many of you industrial research centers of different companies. People do not really understand what is it. Because it's somehow shadowed or hidden by similar and more popular domains that I list here, such as software development, AI, machine learning engineering, and another branch, applied mathematics in physics and similar matter. So I feel that what we do at Huawei, for example, not necessarily at Huawei, in some other companies, what we do at Huawei is kind of science. So there are people who are working with us, like Adyan, and they already know how it looks like. And my target is to share, not of course what we are doing, a job, but to share the idea that algorithms may become an interesting domain for mathematicians. So all of you guys are students of mathematical faculty, is it right? All of you guys from mathematical faculty, do you? Yeah, including you, yeah, right? So you selected theoretical mathematics. I appreciate your choice. And I'm here to tell you, guys, you're on the right way. You don't need to switch to software programming or AI if you want to continue research. Algorithms is a domain where you can find your interest. And that's our course about, to share the idea that in all algorithm stories, there is some mathematics to share and to understand and to investigate. You should be very clear that the course does not target to get you a complete algorithm course, like Yandex data analysis school does, or like 1 or 2 years programs at different MIPT faculties or computer science faculty of HSC. They target at having engineers who are familiar with the whole bunch of algorithms stories. Our target is different. Our ultimate goal is to reveal a specific beauty of algorithm analysis. Yeah, sounds a bit, high level, but it's really so. I hope you will see it just today, but definitely in next lectures. However, even though that we talk about mathematics, but it's impossible to understand any algorithm if you do not program it by yourself. So the only way, it's absolutely clear, the only way to understand some approach, some algorithm, some data structure is trying to do it by yourself in some algorithmic language, or at least if you think about that on a paper. Even in this stage, you understand, you feel, and you find lots of holes in the introduction you are familiar with. So, besides theory at my lectures, besides solving problems on a paper that you will be doing, led by Georgi, we also will have specific tests, automated tests on the web or the Codeforce resource. So you will have to pass all these tests to be successful at this course. And this is absolutely mandatory condition, as we will see further. Yes, not only algorithms. So a typical misunderstanding is that algorithms are regarded as algorithms. Like algorithms does this, this, this. No, algorithms and data structures work together. No algorithm without data structure. No data structure without algorithm. They work together, and the famous mathematician Donald Knuth said that algorithms plus data structures equal programs. This is the title of one of his seminal book. And we will be happy to see your progress. And if you will like this domain, and if you will be successful in this domain, then actually it's possible to continue. For example, we every year, every summer, for sure, we hold a lots of internship program in different domains. For example, just to say, in our lab, we are about 70 people, about 10 teams with different size and very different directions, and you can select what you like. Like Adian or Leonid, who was here previously. So we have at least 2 people in this course who already joined us as intern, then stayed for a while, and then select maybe something else. So that's it about our, how to say, target. Now, important, what is prerequisites of our study? We should be absolutely clear. The mathematics we will talk about is simplistic. It's very simple compared with representation theory, algebraic geometry, topology, etc. It's simple. So no much requirement about mathematics is needed. All of you guys, all students of math faculty are eligible for this program. So even the first year's students may apply. From first year of bachelor to second year of master, everything is okay. But we have 3 essential conditions for students to meet. First condition, our study will be offline. So we do not really think that we have some online interaction during the our course. Why? Because this significantly slows down our progress. And you are enough experienced to appreciate this offline method. In particular, people drop me email saying that, okay, I would like to apply, but I am abroad. Sorry, impossible. So you should stay in Moscow to follow this course. Second condition, test programming. This will be fully online, and I will give some word to Alexander. He will probably introduce his idea and requirement and himself. But what you should understand is you need to have your computer. So you need to solve by yourself the access to some computer. All of your programming tests, not tests, programming hours will happen in online mode from home, for example. But you need to have computer to do this. You need to have computer installed, C++ setup or Python setup, be familiar with this, able to work with this, able to do programming, and also able to upload your solutions to the server, run the test in there, and this is in permanent basis. So without equipment, it's hardly possible to do. No. I talk about specific days which will be fully dedicated to boost your programming skills. Not today, next week. Next week will be the first online, seminar with Alexander. Alexander will later on tell you how to do. And the third one, you should be able to and willing to doing programming. So the criterion will be that you need to pass successfully the first test. So next week on 26th of January, Alexander will give his first, first lecture, first seminar, and first list of problems in Codeforce. Then you will get 2 weeks to finish it. if you are not able to finish it within 2 weeks, you will not be continue this course. So after, more or less after February 9, it will be clear who can, who cannot continue this course. I think it should be clear. Now about the structure of our course and the scoring, because after all, we need to evaluate your performance. So how we'll do it? Every week you will have either offline 4 hours with me and Georgi, or online 4 hours with Alexander. And first lecture, then seminar when we will consider problems and we will discuss how to solve them. Then you will get a list of problems to be solved at home and report the solution in written form. All our problem list will be uploaded to Google Class page of the course. Who apply for Google Class? Please raise your hand. Not everyone, please do it who didn't do. Problem solution should be reported in written form as a readable file. Either you use TeX, and use PDF LaTeX, for example, to generate a readable text with formula, or if you don't master TeX, I don't know whether such people exist here, you may use Word to write down text and use Microsoft methods to draw formulas. It's also okay. But TeX is, of course, better, especially for mathematicians. The solution, by default, is in Russian. However, if you do not master Russian, you will report in English, and your examiner will also use English for interactions, no problem. The first problems will be used to control your readiness to work. So today, we have already published our problems on the Google page. Next Wednesday, this is deadline for solving. Yeah. So, who did not solve the problems in the first list by next Wednesday midnight will not pass future program. But this first list is extremely simple according to our opinion. So maybe even too simple. So you will see it's not rocket science. You are able to do it if you want to to spend time on this. So it's just the check for your, how to say, attitude and ability to work. Question? No? But in future, it will be more relaxed because you will have more assignment, and we don't expect you be so reactive to our requirements. So you will have 2 weeks to solve any list of problems, typically. After 2 weeks, close. Solving means you may solve not everything. There is some scores for every problem, and you will have the sum of the solved problems. I hope that the lecture will be recorded and placed on YouTube. I am not sure it will be all the time, because for today one told me that it's impossible. It's really possible. I'm happy. Hope it will work the same in the future. The lecture that I will show, my lecture will be a PDF presentation, and I will also upload it, but I need to proof check for typos, so you shouldn't expect it immediate after the lecture. So it's better, that's why it's better to follow offline lectures. We established a Telegram chat, and I guess all of you guys are already in Telegram. Are you? Okay. So I just write, so if someone doesn't use Telegram, like me previously, I did not use Telegram, I used not to use, I just apply for Telegram for you guys, just to communicate for you. But if there is anyone who doesn't want to use Telegram, there is email, there is Google Class, this is another way. Okay, then the formula for the score. Every problem will be evaluated with some score from 0 to 10. And then the scores of all lists are averaged, and this average score of all problem solving will constitute 1/4, 25% of your final score. Another 25% come from code force tests from Alexander. Yet another 30% will come from your written exam at the end of, in June, let's say, in June, May, June. And 20% of score will be from the control written exam after the end of third module at the end of March. That's the formula of our interaction. I think it's pretty clear for you. So any questions so far? If no, let me introduce Alexander. Александр, вы меня слышите? Ага.
Hello, I'm here.
Uh,
I'm glad to see you.
ага.
We will work on the programming part of this course. So the next class will be by me online. I will tell you about Code Forces platform that we will use for submission of our code. As Dmitry told you, there is a big difference between writing your solutions on paper and writing the code that works. And it's very important for our course that we have programming assignments as well. So you will learn how to not only solve algorithms mathematically, but also how to write code. So the more details will be next time, the beginning of my lecture. And also I want to mention that since my classes will be online, we shall select proper time for them. So if it's not convenient to you to begin at this regular time, because, for example, you go home after your classes, we can shift our begin maybe an hour or into hours. So we will discuss the time of the next class in Telegram.
Yeah, so let me clarify. Alexander, let me make it more clear. So the idea is we think that, okay, our typical hours is 4:30 till 7:30. It's not too much late, but this is kind of late. So maybe some of you guys prefer to go to your home or to your dormitory and take the course from there. And for this, you need some time. And maybe it would be more convenient to start not at 16:20, but maybe 17 or something like this. So please think about that, and let's discuss in the chat what's the optimal time to start, so that it will be convenient for everyone. For Alexander, it's not big deal to change from one to another. He just needs his 3 hours of your intensive work, but when these 3 hours will be in the second half of the day, doesn't matter. Okay? Please think about it. Александр, продолжайте.
So I think this is it.
Okay.
If I shall add something, please tell me.
Let me ask students about questions. Я еще хочу сказать такую вещь. Если у кого-то, кто-то понимает английский, но стесняется задавать вопрос по-английски, потому что не настолько им владеет, пожалуйста, задавайте по-русски. Это абсолютно нормально. То есть я имею в виду и прямо сейчас, и во время лекции, когда вам будет угодно. То есть есть кто-то, у кого с английским проблемы? Таких нету. Ну, в общем, вопрос. Мы опубликовали систему, она довольно жесткая, и мы хотим ей исследовать. Мы не знаем, сколько останется людей после 9 февраля, но все, кто останутся, мы им всем рады и будем помогать справляться с этим заданием. И у нас есть запас людей, которые помогают проверять все эти листочки, так что мы готовы к любому количеству, в принципе. И мы бы хотели, чтобы вас было как можно больше. В то же время эти условия сформулированы таким образом, что те, кто будут тормозить весь курс, те, кто не смогут справляться с курсом, они могут, например, подождать, потому что я планирую каждый год весной читать такой курс, в следующем году. То есть мы хотим это делать на регулярной основе. No questions? Okay, great. Спасибо, Александр. Я тогда отключаю вас. До свидания. Ага. Так. Okay, before I start, several things to be clarified. First of all, we have some typical textbook which can be of use, can help you. Two books needs to be mentioned first of all. Корман Лизерсон Рибест, algorithms, I don't know, in Russian, построение анализ алгоритмов, especially the first Russian translation by Alexander Shen is the best one. This is a super beautiful book. However, it has some inaccuracy somewhere. Another book where the quality is much better is Dasgupta and others. It's mentioned in the list of literature. This book is much shorter and very carefully written, so you may refer to it. However, from my side, I try to take every source from every book, from my experience, and build up the course which will be good for mathematicians. Because many courses, they are not written for mathematicians. They are written for programmers, first of all. So my target is to have absolutely clear everything. Just very simple and very clear. My target is to make you guys understand algorithms is very, very simple at the end. If you pass it in some curve, you will understand everything. So if you have any concern, any misunderstanding, please don't hesitate to ask me. My target is to make everyone everything understand. It may even seem to be simple at the first glance, but later on you will see how much you will learn. This is first. In the second, I am not used to use black box. For a long time I did not use it. So I prepared my slides. And slides is a specific art. So you should not expect slides to be understood as mathematical paper. It's written as illustration for my talk. The difference will be clear. So sometimes it's written one word, but this word can be explained and becomes a clear explanation. Yeah? So do not judge about the slides too much severe, that they are not good enough because something is not written accurately. I understand maybe your concern, maybe Georgi also shared with me some concern about some of my points, but I most of all want to do the following. A proof of every theorem is on one slide. It should be very small and very clear. Okay? Okay, let's start. So this is outline of my lecture. I start with the understanding what algorithms are at all, because even this simplistic question is very, very, how to say, confusing. Then we talk about complexity and give some examples. Then, to have something more or less essential and interesting, we will talk about divide and conquer principle and binary search. Okay, so the word algorithm is everywhere. People say algorithm, algorithms of machine learning. What is your algorithm? Especially non-professionals say, what is your algorithm? And sometimes it's impossible to answer because it's full misunderstanding. As a very typical case of misunderstanding, I show you an example of interview. So this is my personal experience. I do many interviews. People come to me and we discuss what they know, what they don't know. They apply for a job. They think they know something, and I ask them about something, and I used to ask them about something. Yeah. For example, I may ask, do you know Euclidean algorithm? Does everyone know Euclidean algorithm? I hope so. Yeah. Looks like it's very simple. And the guy, not about Euclidean algorithm, about something else, may answer like this. Okay, I know Euclidean algorithm. What is Euclidean algorithm? I have to my non-negative integers a and b, and I just assume that a is greater than b. And then I divide a by b and get remainder, and then I do... Stop! Telling him. It's not the right way to talk about this. Because algorithm is not a list of actions you do, it is meaningless. Algorithm starts from asking what problem you are trying to solve. And believe it or not, many algorithm introduction are lacking this explanation. Many people who come and say, I know machine learning. I ask, how about this topic? Oh, I know, it's so simple. I say, please tell me what is it. Okay, we do this is it. Stop. What problem you solve? He doesn't know. In many cases. So I'm serious. It's not about just ignoring the problem statement. It's about misunderstanding about the main principle. So you cannot do any algorithm discussion bypassing a very difficult discussion of what problem you are going to solve. And this is what I want to talk about on example. So algorithm make only sense if it solves, at least approximately, some well-posed problems, such as to find an object that fulfills some constraint and fits the objective feature, such as extremal value of objective function. This is kind of definition I wrote down, yeah? Like nonsense. For example, let's talk about Euclidean algorithm. What does it do? It finds the greatest common divisor of A and B. What is the object? Here the object is natural number. Natural number, not arbitrary number, not complex number, not periodic number. Integer, just this. Constraint exists here. What constraint? Okay. What we look for, a divisor should divide both A and B. Otherwise, we don't care. What is the objective function? Just the absolute value. So we are looking for maximal absolute value divisor of A and B. That's what we are doing. Please. Ограничение в контексте особенно оптимизационных задач, вот как бы есть целевая функция, а есть ограничение, которым удовлетворяет. Okay. Moreover, every algorithm, every problem, algorithmic problem should be clear about what should be input, what should be output. And the very first questions are, if we finished this, for example, my greatest common divisor. Okay, this is the problem statement. Then I should ask myself whether a solution exists, whether it is unique, and what the expected algorithm should do if non-unique. All these basic questions need to be addressed. Let's start from what you definitely know, linear algebra, solving linear equations. Yeah? A multiplied by x equal b. A is m by n matrix, x and n by one column matrix, and b is m by one column. Okay, this is problem statement, is it? Looks like that? Is it the problem statement? A multiplied x equal b. Is it the problem statement? No, it is not. Why? You say, why? We have plenty of algorithms. We have Gauss methods. You know Gauss method? Who knows Gauss method? Who knows Jacobi methods? Nobody knows Jacobi method. You know Jacobi? Do you? Great. Great. So someone knows. And someone may wonder, why Jacobi if there is Gauss? Okay. What is LU decomposition? Who knows LU decomposition? Actually, it's the same as Gauss method, but implemented as matrix decomposition by some reason. Doesn't matter. Just mention there are plenty of methods. These 3 and 10 or 20 more methods which solve this problem. Numerically efficient. But what does the solution mean? Does it unique? Does it exist? Yeah. So here, as you guys all know, this is the very basic of linear algebra. Teachers teach you to some vocabulary, some words. You talk about determined, indeterminate, overdetermined system. По-русски определенные системы линейных уравнений, неопределенные системы линейных уравнений, переопределенные системы. Кто знает, что такое переопределенная система линейных уравнений? What is overdetermined? More equations than variables, right? На самом деле она даже не совместна, может быть, иногда. Homogeneous and homogeneous system, yeah? These words are absolutely mandatory to pose the answer, to formulate the answer, fundamental solution. The answer is the linear combination of some solution plus the arbitrary linear combination of fundamental solution. You all know this. I do not think I tell you anything else. Just think about that from the under the angle of trying to pose any problem. So you need to come up first with some theory about what you are looking for. And without this theory, you may not tell you solve this problem. You have to answer what is your solution exactly. But even in this simplistic example, just one change, everything changes. Input assumption. We didn't talk about this yet. Here, everything is real numbers, right? By default, it's real numbers. Not complex numbers, for example, not rational numbers, just real. We think about that. But actually, every field works, yeah? Of characteristic 0 at least, yeah? So maybe it works. But what if it's ring? What if we talk about integer solution? Yeah? Same problem. Absolutely same problem, but we just change the requirement about solution. Okay? Linear algebra just doesn't work. Jacobi doesn't work. Gauss doesn't work. Why? Because they use division, and we cannot divide in the ring. It's natural to assume that both the matrix A and B are integer. And actually, it's called system of linear Diophantine equations. So, without insisting on the content, let's just think about that. Let's just play. We are talking about solving linear equations, Diophantine equations, as an example of what changes compared with the real case. Okay. What is similar? Similar is the vocabulary of fundamental solution, homogeneous, non-homogeneous. Everything works fine here because this is about addition, not about division. So you always may expect that your solution is again a sum of these guys, but they all should be like integer. Okay. Then if you pass to homogeneous system of equation, then it's nothing but looking for a abelian subgroup in a free abelian subgroup. Yeah. So here it was linear algebra. Now this is just abelian groups. Looks like at first glance as different category. It's not actually, you know, this is modules over rings, but anyway, this is what you can understand. You have fundamental abelian group theorem that the solutions is a free abelian group generated by linear independent over rational fundamental solutions. But how to find them? How to find them? Okay, here's the way I show, just for your information and to understand that it's really an algorithm, even though it's a bit different. One of the ways is to use Smith normal form. You have your matrix A, and you look for matrices U and V, which should be with determinant 1, invertible. And the product U by A by V should be diagonal. And Smith proved in the middle of 19th century that such a decomposition exists. And then if you take your equation, yeah, maybe it's worth writing. You have AX equal B, and you have C equal to U A V. This is diagonal. Then you take this and multiply from U from the right, and you get U A V V minus 1 X equal UB, right? So you call this guy Y. This is your new variables. And this is C. This is diagonal matrix. So you first solve the problem. CY equal UB. Yeah? You know U, you know B, you know the right hand side term, you know C, this is diagonal matrix. And this is kind of simplistic possible Diophantine equations, which solves or not solves depending on the divisions of coefficients here by corresponding diagonal elements here. And then if you find Y from here, yeah, then X is V multiplied by Y. So this is the algorithm, which is purely integer. You don't need to do divisions, yeah, because you invert matrices with determinant 1, so this is integer. Okay. It remains to find the Smith normal form, but you may visit the paper of 19th century if you like. So what I'm talking about? I'm talking about what happened. You have linear system topic in traditional linear algebra. Then you change the condition about input, and you get absolutely different algorithm. This should be very clear. Which means even traditional problem statement to be found in textbook, when you come to reality, for example, to the industrial application, something change and everything change. And then this everything waits for your work. That's what I'm talking about. Let's pass to complexity. And let's start from a specific example of the algorithm problem. Okay, we have a list of numbers. Лист, просто чтобы сказать какой-то список, множество, в общем, чтобы не использовать какие-то специальные слова. List of numbers. So the input is the sequence of integer numbers. What we need is to find a member of the sequence with just maximum value, and with this maximal index, with the minimal index, to get the answer fully determined. So if I don't say, if I just say find an element of the sequence with the maximal value, what's my problem? My problem is more than one solution in general. Yeah. So to resolve this ambiguity, I say the one with the minimal index, and then my problem is obviously well defined. There is a solution. How to find it? Well, you guys all know how to find it, but let's wait for a while and play like we do not know how to do it. Like we are automated computer which doesn't know, I mean, trivial things. Yeah, brute force algorithm. Brute force, everyone know? Yeah, полный перебор. В общем, самый, как бы, неэффективный алгоритм, который только может быть. What we do, we write all numbers in one-dimensional array D. Then we just check every pair Di and Dj and write 1 to the entry Cij of two-dimensional array if Di is greater than or equal to Dj and 0 otherwise. Yeah? So we process the matrix D and we fill in the matrix C. And then how to identify the solution in this strange mode? Okay, the index which stands for the maximal should have the whole row equal to 1 because it is greater than or equal to every other element. Okay, and to fulfill the condition, the minimal index, it should be the upper possible the topmost row. So obviously it solves the problem correctly. When I say obviously, I put the question mark. Why? Because if I would consider this as a problem for automated deducing, proving, it's not so obvious. I am not sure whether it's possible to solve for the provers nowadays. But how about efficiency? Yeah, what is the efficiency of the algorithm? In general, we measure the efficiency by working time, and this is a separate big question: how to estimate working time? But anyway, it's a number of operations, logical operations, arithmetic operations. This is about, how to say, the size of the program, and also we have the size of the memory. Sorry, not the size, the latency of computation. Yeah, how much time we need to wait until we get results. This is the first parameters. Another parameters is how much memory shall we occupy to do it. So let's analyze our brute force. We n times write to the array, n squared times do initialization of the array. Never forget to do initialization of an array. Then that many comparison, and for each of them 2 times write to the array. Then we do that many summation over the row to identify where all ones. Yeah, how to know all ones or not all. Sum up and compare with n. And finally, at most n comparison of the sums with n. Totally, the number of operations is 3n squared plus something. And for memory, we use n for D and n squared for C. So n squared plus n total. So pity. So brute force is really expensive algorithm. Now we come up with the formalism we will be systematically used in this course. You know, I think all of you already know O log n, O n, all this notation. Yeah. Now let's do it more precise. First, we start with theta formalism. So we show that the brute force has number of operations 3n squared plus something. But in most cases, we only care about asymptotic of this function. Even the leading coefficient may not be important. So in this respect, we say that brute force is theta n squared complexity. Then definition. For every function taking natural numbers to real numbers, we say that some algorithm has complexity theta f if there are positive numbers c1 and c2, such that for every input of size n, the number of algorithm separation is between c1 fn and c2 fn. Sorry. In particular, if it's whatever polynomial of degree k, then we will say theta n upper k. Yeah, because here in precision, the leading coefficients may not matter. Actually, it matters sometimes. It always matters. But sometimes we just say theta n square. Do not distinguish 3n square or 100n square. Actually, it matters. But in many cases, people omit this information. Okay. Then O and omega. So let f and g be some functions. We say that f is belongs to the class OG, and in this case, g belongs to the class omega f if there is some positive constant, such as the ratio is below c for any n. In particular, n log n belongs to O(n), for example, to the 1.5. Yeah, we all know that logarithm tends to the infinity, but slower than any positive power of x of n. That's the case. So the definition that an algorithm is called polynomial if in some O(n) k for some k in n. And the main focus for this course are polynomial algorithm, and there are more precise, wording, linear complexity, quadratic, cubic, also logarithm or n log n. This is the 99% of what we talk about is of this class. But the fact that I draw your attention to is that problems can typically be solved by algorithms of different complexity. So we may and will talk about upper and lower bound of problem complexity, not on of algorithm complexity. You should be clear. So there is the complexity of specific algorithm, known or unknown, provable and unprovable. That's not always absolutely clear. You should not expect that every algorithm is easy to answer the question, what is this complexity? But besides that, the problem it is going to solve may have different complexity. And in the next lecture, we will talk about the low bound of the complexity, most of all. So, upper bound for a problem is, we say that the problem is of class OF if there is an algorithm in OF solving this problem. So if there is at least one quadratic algorithm, then this problem is at most quadratic. Low bound is vice versa. We say that the problem is on the class omega f if it can be proven that non-algorithm which has smaller complexity than theta f solves the problem. Here you may feel that this is not easy to prove. How to prove that non-algorithm can solve the problem fast? How to do it? Do we have methods? We do have methods, and we share with you methods to prove this. Now we talk back. We go back to our maximum function, and our brute force turned out to be ON square. Does it really belong to omega n square? Is it a real low bound? Okay, we consider another algorithm for maximum problem that you probably all know. I call it natural. What we do, we write all numbers in one-dimensional array, set integer variables, max index to assign with -1, and max val is minus infinity, and then I run integer index from 1 to n, and whenever the next value di is strongly more than max val, then I assign max index with the current index. Okay, let's think about the algorithm. It works fine. Let's think a bit. Everyone understand it works? Георгий, можно вас попросить сделать несколько фотографий меня и всей аудитории? Мне нужно. Is it clear it works? Who doubts, please? I don't change max val because I get my index, and then I just return d value passing max index to that. Okay, why it works? Why it was fine? Because I go from left to right, and if strongly more, I jump my I switch my index to a next candidate for maximum. If equal, I don't do anything, so my first appearance of the maximum, I will retain it. So I will take the first, please. Нет, Максвелл у меня... Да, я забыл написать. Да, совершенно. You're right. Maxwell should be assigned. Should be reassigned with the d sub I. Okay. Okay, it works. Now, what is the, how many operations? Just 2 assignments before the loop, n loop steps with 1 comparison, at most 1 assignment in each step. So totally 2n plus 2. How about memory? Just nothing, n for d and 2 integer values for max index, max val. So natural is theta n complexity, and therefore maximum problem is of linear complexity, not quadratic complexity. So why I talk about this absolutely simplistic example? You should understand, for every problem there might be different solution, different algorithm with different complexity. And one of the theoretical target of computer science is to to improve the low bound. Ясно? So this example is mostly about that. Please, your question. Теперь да, да. Okay. How about the low bound? Can we say that the algorithm belongs to omega n? Yes, it's right. But we'll prove it next time. We will give you the methods how to prove it. Another remark is that this algorithm is also beautiful because you may avoid writing to the array. You may do it online. Just check every next element, compare with your retained maximum. That's it, which also saves your memory. And your memory is constant. Okay, now a bit of complex stuff to show you that here we did not finish even with this simplistic problem. It's not finished. Why? Parallel implementation. You know, nowadays many computers have multi-core, and sometimes you can do everything by using parallel computation. And here I briefly, in this plot, I introduced the algorithm how to do it in parallel. It's totally different. And this not completely trivial calculus shows that it really does speed up k times, where k the number of workers you apply. Okay, first of all, what's the algorithm? Let's start from the assumption that you have 2 to the power k different numbers. In this particular case, 8 numbers. So you split them in pairs, and from 8 you get 4, from 4 you get 2, from 2 you get 1. So all in all, you have 4 plus 2 plus 1 comparison, 7. 7 comparison. How many comparison you would do if you apply natural? The previous algorithm. How many comparison? 7. Also 7. Yeah. Yeah. So what's the value? What's the gain? The gain, because we can do these 4 in parallel and these 2 in parallel. So we may, if we use 4 parallel cores, so instead of 4 times, we get just 1 quantum time, 1 quantum time, 1 quantum time. So instead of 7 quantums, we have 3 quantums. Parallel computation does kind of speed up. You may ask, oh, come on, for 2 to the power k is easy. How about any other numbers? No problem. Let's assume you have, let's say, 5 numbers. So you just ignore last 3 nodes, and in this comparison, so you have here you have nothing, minus infinity. Here you have comparison of something with minus infinity. So you directly put it here, and then only you compare this 5th element with the result of the left branch. Yeah. So this algorithm really applies to any number of samples to be compared. And then I claim a theorem that parallel binary tree algorithm has k times speed up compared with the sequential algorithm. Okay, why? So that formula shows you the latency. How to understand this formula? This guy upstairs is what? Here in this example, this is what? This is 3, right? If n equal to 8, this is 3. And 3 means here 1, 2, 3. 3 layers of comparison. Because these layers, they are sequential. So the time, the latency is the sum of. Now, for every layer, you apply k workers. You have that many tasks, n divided by 2 to the power I. Yeah? And then you distribute them over k workers. it may be not integer, then I place here upper round up. So this parentheses mean I take my closest integers more than the number, and if lowercase smaller than the number. Yeah? So this is clear why the latency is like that of workers. Okay, and then we apply some calculus to see that this is really like this. Look how I do it. So this is my latency. Then I do a natural trick. I replace the taking integer with adding 1 to every term. Then I separately compute all my ones, and I get what? I get, by the way, what I do, I divide this guy by n. I divide this guy by n first. If I sum up my ones, I get this term finally. Logarithm divided by n, and it tends to 0. It doesn't have any contribution to the sum in the limit. So I get rid of this guy, and I then have n and this n divided by themselves, and I have this sum. And what is this sum? 1 sub k goes out of the summation, and this is just sum of 1 second, 1/4, etc. This is just 1. So I get exactly 1 divided by k. That's it. So you can see that for whatever algorithm, when n tends to infinity and k has some finite value, 3, 15, yeah, you have a good proportional speed up of your computation. This is very good for parallel computation, the top best which you can expect. But here is to show you, even the extremely simplistic algorithm problem, when you take into account some problems, some hardness like parallel computation, gets absolutely unexplored domain. Go ahead. Not all problems have a polynomial upper bound. You should be clear that exponential problems do exist, but it's also not clear. It's also explorative topic. And I tell you this story about very clear and popular topic, prime number test. The input is the number, is integer, and you need to know whether it is prime or not. Yeah? Well, there is a very simple algorithm, everyone knows it. Just take every integer from 2 to the integer part of square root of n, because if any divisor exists, it should be in this range. And just divide, and if remainder is 0, then it is not prime. If it's always 1, it's prime. So this is an algorithm. What is the complexity? The complexity is square of n. So is it polynomial? Obviously not, because remember, what is the complexity? This is the latency compared to the size of the input. So what is the input? The number. What is the number? The number is the sequence of its digit. So the size of the number is not the number, is the logarithm of the number. Yeah? So it's much smaller than the number itself. So the square root of this number is a logarithm, and the square root of the number is exponent, is 2 to the power n divided by 2. So this algorithm has obviously exponential worst case time. So if the number happen to be prime, then you will waste exponential time. You have to. Okay, that's a challenge. Is it any polynomial algorithm or not? For a very long time, nobody knew about this. People believed it cannot be solved polynomial. However, in 2002, 3 Indian guys, as usual, published a very tricky algorithm and proved this type of polynomial estimation. 12 power. Interesting. The algorithm is really complicated. You can search on the web. It's based on number theory. So this is where mathematics may work. And on the other hand, in practical sense, O(n) 12 power, nobody will use it. So this is polynomial, yes, but this polynomial is too much. Then there is some conjectures, non-proven conjectures, but not, how to say, contradicted conjectures. Under these conjectures, the algorithm works faster, n to the power 6. This is very important, you should understand. Sometimes you have algorithm known, some estimation of its complexity known, but not only the problem itself have no low bound. Even the algorithm estimation may be far from being precise, because estimate is what people can prove. People cannot prove too much. And there are lots of algorithms where the estimation are very bad, but people are using this. Why? Because it works. Heuristically it works, but nobody can prove why. This is also reality. And another example, so if we take that same problem, but we don't just stop on saying prime or not. Let's ask ourselves, get the factor n into product of primes. That same algorithm that I showed definitely works for that. We just take one divisor, divide, and then continue. But how about this problem? Is it ко мне? How about this problem? Is it polynomial like the upper one? Nobody knows. That's exploratory research. You may do. Okay, let's come to the last topic of today's lecture. I will try to speed up. Divide and conquer principle, which is one of the most simple and beautiful heuristics that you will learn today, or maybe you already know this, and which applies in many cases. And for example, you will apply it in your problem list. For your information, I just explored that divide and conquer, разделяй властвуй, да, все знают этот принцип, слышали? Where does it come from? Julius Caesar, and even before him, Philip II, the father of great Alexander, already applied this principle. Okay, after this historical remark, what is it in algorithm? The idea is somehow decompose the problem into several similar, simpler ones, solve these subproblems, and combine their solutions into one for the whole one. Decompose the problem into smaller ones, solve each of them, and use the solution of each of them to get the solution of the original problem. That's the idea. And we start with probably the simplest example of this principle, binary search. We talk about element query. Okay, what's the problem? Assume you have a large set of n different integers of any other objects with integer indexing. What you need to do is to organize your data the way in a structure that allows to answer a standard query. For some integer q, return the position in the structure where the number is stored, or 0 if it's not present. Requirement like this, problems like this will be very standard in my first half of my course. In many data structures you will do something like this. How we do? First of all, we do preprocessing of the data. How we do? We sort numbers and put them in a linear array from smaller to greater, ascending order. How to do it, we will discuss next lecture. And then, what is the binary query? We have we query the number q, and what we do? First of all, we exclude some corner cases where the answer is definitely not present. This is when q is behind the range of the array. We compare with dn and d1, and if it's beyond the border, we return 0. Then we set auxiliary variables l and u, assign them with 1 and n, and these are going to be the low bound and the upper bound on the segment we are exploring. And then we apply while loop. While L is strongly less than U, what we do? We compute the middle of this integer segment, round up, down, take the corresponding element of the array, and if it's smaller than Q, okay, it means Q is to the right hand side of I, so I recover, I change, I update my low bound with I, or if di is bigger than Q, then my upper bound needs to be updated, or else means di is exactly equal Q, I return I. And that's it. So this diagram shows how it does. If we check this array with the query with 4, we start from 1 and 14, take the middle 7, compare 4 and 7, go to the left, then go to the right, and find 4 here. Such an algorithm. It should be absolutely clear to you guys that it works, but let's try to be more specific. Why does it work? How to prove it works? How can we prove such statement at all? Here, an important concept is helping, which is called invariant. Invariant. For me, who was doing invariant of group actions, this is somehow confusing, but anyway, it's very popular word in algorithm discussion. Invariant of a loop. You have an algorithm with looping, and you say, while in the loop, you have, and then you consider some function that takes as input the data in your loop, or a statement about this function. What invariant can we show in this algorithm? First invariant. Before and after every loop holds true. Q, the required index, is between I and U, always. That's why the problem is solved correctly, because we work with the window narrows down, and finally what? How we get correct value? So we, at some moment, our Q gets equal either to U or to L. If we pass all these loops to the end, we probably didn't find it, and we return 0. Yeah, Q is a value. Yeah, Q is a value, not an index. Yeah, it's kind of typo. Yeah, we compare Q with the values of the array. And you see, we come up with another invariant, W. W is the range of the window. And then if we introduce previous and next range, then we see that next range is almost equal to half of previous range, which means exponentially goes down, which proves the following. The algorithm returns the correct position of Q and D, if exists, otherwise returns 0. Yeah. By the way, because it's exponentially decreases, there will be finitely many steps. Yeah, that's why. And second, the number of loops and the algorithm complexity of the class of theta algorithm. These things should be clear. And this is beautiful. So instead of looping of all elements and applying visiting every element, you just apply binary search, and very fast, in log of time, you find your element. Very quick, beautiful idea. Brilliant idea. Simple, but brilliant. And we, all the time, will talk about such things. Let's go further. Not just element query, there is some range query. What is range query? The same context, you have different integers. Then you need to come up with some data structure so that you are able to return all appearance of your data structure members in the range from A to B. So you do not look for one element, you tell, give me all elements from from A to B. Again, we do preprocessing and data structure. The same way we sort numbers in linear array. Then this is the binary range query algorithm. First, we handle extreme cases when my range is strongly outside the range of my array. Yeah, so my array is from D1 to Dn. If my A is greater than Dn, is to the right from my array. If B is smaller than D1, my range is to the left of my array, nothing to return. Then if my A is smaller than D1, I swap A to D1 because I don't care about the interval between A and D1, nothing to change. This is preparatory. And after this, I can call element query, same as in previous page, but just one small change. Actually, it was some special introduction, but I put it here in small text. So what I do, I add some additional variable equal to 0 or 1 to give instruction what to do if the element is not present. Because when it was talking about element query, if element not present, clear, return 0. But if A is not in the array, we still want to find the closest array member. And also we might be willing to find the closest to the up or to the down. So my additional variable, 0, 1, says to find to the up or to the down. Yeah, this is preprocessing. Yeah, of course, yeah. So, yeah. So these additional variables, I hope it's clear what does it do. And then I apply this algorithm, and I find my top left and top right index in the array, and I just print out all my array elements from S to F inclusively. That's it. What's the complexity of this algorithm? The answer is not obvious. Because what we see here is this constant terms. Here we use binary element query, which has logarithmic. Yeah. But then I have to return a list of elements. So if my A and B were minus infinity and plus infinity, then I will have to return all my array elements. So the complexity of this algorithm depends on the size of my answer. No way. You cannot have algorithm which have logarithm complexity if your answer is linear complexity. So here is another story you should be careful about. When we talk about complexity, it's not only subject to the size of the input. Sometimes it's subject to the size of the output. And smart algorithm and stupid algorithm have the same complexity in terms of the input, but have different complexity in terms of the output. Okay, how about higher dimensions? Oh, this is complicated and long story. I will briefly introduce you. In two-dimensional and three-dimensional space, it's absolutely the same way we may consider range search. It means instead of, let's talk about 2D for simplistic. Instead of one interval, we have two intervals for x variable, for x coordinate and for c coordinate, right? And what we want is to find all elements of my set of points M in R2, which belongs to this rectangle or range. Yeah. Is it clear? We have points, maybe a beautiful illustration here. We have many points and we come up with some range. And on this range, we would like to identify all the points. Okay, as usual, we need to come up with some smart data structure which makes our algorithm working well. What we do? We try to, first of all, to hope we may do logarithmic search. Do we? Right? So for 1D, we did it. I said, it's obvious. Everyone can do it. So we also can do it for 2D, right? We should do it. Disclaimer, spoiler, it's impossible. But okay, let's do it. How we may do the simplest way? Okay, let's sort the points according to their y coordinate from bottom up. Bottom up, but there might be points having the same y. How to distinguish them? They have the same y coordinate. How to do? We just put them in one set, m sub beta. So m sub beta takes all my points with the y equal to beta. And also I may put order in my m sub beta by sorting them by x coordinate. May I? Why not? Okay. Then I come up with my fake binary range query algorithm. Be careful, it's fake. What's fake, we will understand. The algorithm is not fake, but the idea is fake. So how I will do? First, I will apply my one-dimensional binary range query in y coordinate. So I will find all horizontal subsets such that beta belongs to the range CD. It's possible, right? Then I get a union of m beta over some beta. And then for every of these m beta, I apply one-dimensional binary query to get the points which belongs to, with x belong to AB. Possible? Possible? What's wrong? Okay, it's written here. Because of the features of one-dimensional binary range query, both steps 3 and 4 work correctly and have this complexity. Yeah? The complexity theta logarithm plus k. And the k for the step 4 is really the size of the return send equation, which cannot be changed. But the problem is that key for the step 3 can be just huge, even though the answer is small. Example. Your set of points is like that. Your query is maybe like that. So when you apply your first step, line 3, you get which m beta? All of them. All of them, because I just take my projection to the y coordinate and I see all of them. Yeah? And then on the second step, I have to process each of them. So I will process actually linear time, not logarithmic time. But the answer is that many. This is the true k. It's small. But I have to visit all of them. Bad luck. The algorithm doesn't work. I mean, it works, but the complexity is awful. It means no point to introduce such a complicated pre-computation, given that at the end we may happen to visit all the points. It's useless. Okay, another approach. Define by x tilde the ordered array of x coordinates in my set M. And for every two members of X tilde. So for every alpha and beta, I store all my points who fall into the interval alpha beta in a separate set, and I order them by Y. So I do the following to make it clear. So I have my points. I have so this is the set of numbers. This is my M tilde. And then, for example, был бы другого цвета мел, было бы хорошо, конечно. А, есть такой, да? This is my alpha. This is my beta. And then I have these points. Huh? X tilde, right? X tilde. X tilde. I have my, I don't know which color, green points. And all of these green points, they go to the M beta. And such way I do for every pair of my X coordinates. Yeah? Then I come up with the algorithm. What is the algorithm? So first I do some default cutting out cases similar as before, so that my range belongs fully to the range of my data. And then it is stored. It is stored somewhere. I pre-compute, let's say, an array of arrays, let's say, for example. My first parameter is beta. Sorry, my two parameters is alpha and beta. So I have n times n minus 1 divided by 2 portions, sets. And every of this set is stored separately in a sorted way by Y coordinate. Clear? Okay. Then I apply my binary remain query in this X with A and with B. And this way, I do the following. From this range, I get leftmost and rightmost line containing my points. And then for this alpha and this beta, I visit my corresponding set, sorted by Y coordinate. And then in this set contains all these points. And then it's sorted by Y. And then I come with my C and D and find out those which fall into the interval CD. Clear? Okay, question? По-русски. Sorry, in Russian. Значит, еще раз. Я заранее изготавливаю такую достаточно забавную структуру данных. Для любой пары x-координат моих точек я устраиваю отдельное множество, в котором лежат точки, чья x-координата находится внутри отрезка от этого x до этого x, от альфа до бета. И эти точки там лежат упорядоченные по y-координате. Понятно? После чего мне нужно найти все точки, которые попадают вот в этот вот прямоугольник. Как я это делаю? Сначала я идентифицирую, какое из этих моих множеств мне нужно. Как я это понимаю? Вот у меня есть А, есть Б. Но А и Б, вообще говоря, не являются абсциссами моих точек. Поэтому я использую бинарный поиск. Я сдвигаю А вот в эту позицию, сдвигаю Б вот в эту позицию. Используя вот этот самый алгоритм. Вот. После чего я оказываюсь, я уже по-русски договорил, что всем было. После чего я знаю, окей, я работаю с множеством m альфа-бета, где альфа это вот эта координата, а бета это вот эта координата. И значит, все точки из этого множества мне годятся, только если их y попадают в CD. Значит, я использую другой одномерный поиск и нахожу там все точки, которые меня интересуют. Понятно? Окей, clear. Question? No. Нет, непонятно, что говорить. So let's finish this. Then we will consider your conjecture. Okay? This algorithm, is it clear? Is it clear that it works? Yeah. Like what? No. This one? One-dimensional binary range query. So when we call binary range query here, we don't care about x coordinate. Why? Because we already ensured all our points have x coordinates in my range AB. I don't care about x. I only care about y. Clear? Now, what we can say about this algorithm? Is it good or bad? First statement. Будет? Чуть позже. Ну, если вам нужно идти, так идите. Okay. So first statement, binary range query is correct. We just illustrated it. Second, it used cubic data. It used cubic memory. But it belongs to the required class with logarithm complexity plus k, where the k decides the return subset. So this is our ultimate goal, to have this algorithm. And we reach this goal. But the problem is, we reach this goal with cubic memory. Why cubic? I think it's clear. We have quadratic number of pairs AB, and for every AB, the worst case size of m beta can be all of them, like in my bad example. Okay? So this is cubic. Nothing. Yeah. Low bound. Good question. Thank you. So this is estimate. Worst case. Yeah, you're right. I should have written O, not theta. Right. That's right. And maybe I should come up with the specific configuration showing that this cubic happens. It's right, but it needs some playing with pictures. Yeah, thank you. Right. Oh, not theta here. Another remark. You may think that this is exaggerated size of the memory because actually these sets have some natural structure. So the m alpha gamma, if alpha is smaller than beta, beta is smaller than gamma, then m alpha gamma is just union of two sets. Why shall we store both of them? That's right. But the orders are different. So if you order by y coordinate this set, and then order by y coordinate this set, and then you want to merge them, unfortunately you will have to spend linear time to restore the order. And without order in y coordinate you can't do anything. So unfortunately, it cannot be cured this way. Okay, so let's conclude and show the future of this topic if it's interesting for you. So we have logarithm complexity at price of cubic memory. Is there a logarithmic complexity query with smaller memory? I don't know. Most likely, the answer is no, at least if we are willing to have linear memory. Impossible. I cannot prove it, it's just conjecture. But on the other hand, how about quadratic memory? But even quadratic memory in computational geometry is unaffordable. Too many points. If you have hundreds of thousands of points, you cannot just take it to the square, it's too many. So, there is no way to use logarithm search in 2D. Is it the end of the story? No. Still, there is very interesting, very smart data structure allowing for the search, but not for logarithm, for square. It's called KD3. And it occupies linear memory, and the query complexity is of class square of n plus k. You may visit very beautiful textbook that I refer to. It's interesting. And also, I dare to say, okay, I think I know why is it. Because some of you guys studied algebra, you know, you have real field, you have complex field. All algebra is good at complex, not at real, right? However, real numbers have orders. Topology in real numbers is correlated with the order in real numbers. In complex numbers, you have no order which is compatible with topology. This is a known problem of complex, analysis, let's say, topology. And this is the reason why logarithmic idea doesn't apply to 2D and 3D, etc. So this is a reference, that's it, thank you. If you have any short questions, we may answer, and then have some small pause, and then switch to solving problems. Sometimes, but more than one typo have been shown to me, so I should improve first. More or less. So you mean the way I explain is somehow not exact mathematics, right? So yeah, I think it's okay for your solution. Стиль решения задач. Похож ли он на стиль моих доказательств? Так, ну давайте сколько? 10 минут? Нормально? Сколько нормально? 10? Ага, все.
Остановить трансляцию? А как ее остановить? Она просто задержка. Вот что.